Torque converters. What is it? A device inside an automatic transmission housing set between the engine and the gears. An advanced hydraulic fluid coupling. The torque converter transmits and multiplies engine torque while also allowing the vehicle to come to a complete stop without touching or shifting the transmission. Types of torque converters. Lockup. A lockup torque converter has a built-in locking clutch mechanism. Once the transmission senses a specific speed or engine RPM, the torque converter will use the clutch to lock in a direct connection between the input and the output shafts for better efficiency. Non-lockup. Without a clutch to lock up the torque converter, the turbine can still rotate up to approximately 90% as fast as the impeller, but they do not reach equal speeds, and because of slippage, energy loss occurs. Operational stages of a converter. Stall. During the stall stage, the engine is still turning, as is the impeller, but the turbine cannot turn, so the car does not move. This is what happens when you have your car's engine running, the transmission is in gear, and you have your foot on the brakes, so the car is not moving. Coupling stage. Coupling is what happens when you drive at high speeds. The impeller and turbine speeds are nearly identical at this stage, and this is when some models lock the two together with a friction clutch to increase efficiency. The stator actually mostly stays out of this process, since at high enough speeds, the fluid will be moving in a way that will not risk it hitting the converter housing. Acceleration stage. Acceleration is when that torque multiplication power comes into play. As engine RPM increases, the impeller starts moving faster, which makes the turbine start to move faster, but the impeller is still moving more quickly than the turbine at this point. How to choose a torque converter. One must first take into account the use given to the vehicle, because a car that is usually driven at high speeds on a highway will work better with a different torque converter than one found in a car that does not usually reach high speeds and that stops constantly due to it being driven in the city. Reach out to a car mechanic or a car shop in order to discuss the viable options for a converter that suits your need. It is always a good idea to receive orientation from a professional, or at least someone who has experience with the mechanical aspects and performance of a car's machinery. Select the appropriate size of the torque converters that have been recommended to you, or that you have deemed a viable option to use in your car. The ones with a bigger diameter can handle a greater torque than the ones with a small diameter. This happens because of the components of a larger torque converter are, of course, bigger than the components of a smaller torque converter. Although large converters are not always recommended, since every car operates under different conditions due to the car's weight, engine specifications, and so on. A car operating with an oversized torque converter can have one of the converter's components malfunction due to excessive torque. Make the final choice based on the recommendations that have been given to you and the knowledge you possess about your car. Perhaps someone who mostly drives his or her car around the city does not need a torque converter designed to operate at high constant speeds, but rather one that can operate at slow speeds and constantly stop. Unlike a driver that uses the car for racing and that usually drives at high speeds in a straight line, there could also be a case where the vehicle's configuration is something out of the ordinary, and a very specific torque converter needs to be integrated to the car. Some common problems that may happen with torque converters are, well, a converter may break down and it can be dangerous. Continuous high levels of slippage in the converter can cause overheating, which can damage the elastomer seals that keep the transmission fluid in the converter. The fluid will start to leak out, and when the system runs out of fluid, it may stop functioning altogether. Your stator clutch may also seize or break. During seizure, the inner and outer elements of the clutch can become permanently locked, causing a huge drop in fuel efficiency. If the stator clutch breaks altogether, the stator will free spin and your car may not be able to move under its own power at all. You may see blade deformation and fragmentation in some cases. In most cases, this will cause the torque converter to not work as efficiently, driving down your gas mileage. In some extreme cases, the converter might violently self-destruct. There is a lot of pressure and hot fluid moving around inside the housing of a torque converter. In some cases, that pressure can get too high and cause the housing to balloon or even burst. If the housing ruptures, you're going to be in danger of flying bits of shrapnel and hot oil. Thanks for your attention.